So convergence and serendipity. I mean, seriously wild what's been taking place today. And what really lifted me up is that Filip and I have really only been working on this for about 2 or 3 days. We didn't know each other before. And many of the ideas that are in his presentation are reflected in much of what we've heard today. So hopefully you're going to come away with yet another idea to take home and think about. Before we start, I want to say that I have faith in humanity. I love people. I'm not scared of AI. I want to embrace AI. I have optimism about the future. William S. Burroughs, however, famously said, language is a virus from outer space. It makes communicating ideas really hard. And we are going to do a live demonstration of how hard it is to communicate. Interestingly, we've been speaking a lot today about language. And that what Filip is really going to be talking about is the world before language. And with that, I'd simply say, Filip, why don't you introduce yourself and carry on? Oh, one more thing. Filip turns out to be someone who likes to stand and give a presentation. And so I don't just want to be sitting here while he's standing. I need some cardio. So we're going to both be standing and roaming around.
Thank you, Rafa. And thank you in joining me in this standing position, yes. Okay. I would love to start with a moderately large question, okay? What is the future of humanity? Is it going to be algorithmic? Ben was hinting at that in his talk. And, well, there are signs of that, right? I have been working in the AI space for the last roughly 10 years. I've built an AI startup that was acquired by a larger company. So I've been building AI in a large company as well. And sometime, approximately a year ago, my friends started asking me, hey, look, with this AI, are you going to get us all killed? And it's a fair question, right? We don't know. We don't know. We're just working on it, right? So I started thinking about this Homo apiens, you know, Homo apiens, Homo AIpiens, as possibly the successor of Homo sapiens, and to what extent it's going to be truly algorithmic. And there's several ways how to look at that. The first one is the hard, harsh, Darwinist view that, well, we will simply build something smarter than us, and by definition, it's going to kill us all. I don't really subscribe to that view. I'm an optimist just like Rafa about humanity, right? But there's a more subtle view which might still lead to a similar conclusion. And that is, well, LLMs and human brains have a lot of similarities. So what if we are simply phased out as, you know,
the dominant species on Earth?
The dominant species on the planet, yes. The monkeys at one point, they were the cutting edge of evolution, right? And today they are sort of the cute animals somewhere on the outskirts. Is that what's going to happen to us? We don't know. But human brains and LLMs have quite deep similarities. And it's actually, it's not such a straightforward statement as it seems, especially in the research circles, in the AI research circles. That's quite a controversial statement. Because on one hand, these two technologies are solving the same problem, which is prediction. But the parallels, on one hand, run deep, but on the other hand, they are fairly loose. Okay, we have neurons. The LLMs have nodes. We are running on carbon. LLMs are running on silicon. It's a different implementation of a solution to the same problem, right? So I would like to focus now on how deep this similarity actually runs and what we can learn about ourselves by looking at how AI works, okay? And I have a simple case to consider. Let's say you are standing at a barbecue party in your neighborhood, and there's somebody there who is really charismatic. And your attention is simply drawn to them. You're looking at their movement, their face, how they talk. You can't help yourself but move closer, right? Now, if you pause there, what is happening on a deeper level is that you are sampling that person. You are trying to learn, you are trying to train your inner model of this person, of their personality, right? And by the way, the same thing happens when you are, for example, reading biographies. If you're reading the Steve Jobs biography, you are training an internal model of Steve Jobs in your mind so that you can possibly eventually enact it, right? Now,
So I'm sampling this picture, and the one thing I keep thinking about is I want hair.
who is the charismatic person, right?
Yeah, exactly.
Yeah, it's, you might be training two models at once. Okay, training models. Okay, let's talk about what that really means. So there's a theory in cognitive science that describes how this process actually seems to work. It's the predictive coding theory. We heard a talk roughly about predictive coding before, and it's a pretty interesting field of research at the moment. Because a friend of mine who is deep in that field recently told me this analogy. He said, well, the whole field looks like quantum theory, quantum physics looked in the 1920s. Right? It's a very exciting field with a lot of development, with some competing theories, but a fairly hairy, fairly unorderly surface. So it doesn't really have like a nice version yet. I'll try to give you a 2-minute version of the main idea of predictive coding, but it's a deep rabbit hole, okay?
Filip,
So, yes.
when you're talking about predictive coding, you're
Yes.
talking about in an LLM model or in our brains?
In our brains.
Okay, in our brains.
In our brains. But there's an analogy there, yes? So in our brains. So most people, when they think about how they think that the first thing that happens is that they see the charismatic person. That, as a sensor input, enters their eyes, enters their brain, and then they somehow run a scan against all their past memories and try to understand what is it that they are seeing. Yeah? Am I seeing a man, a woman, a couple, and so on and so on. Interestingly, this is actually technically not feasible. It's computationally not possible to run such a large analysis against the sensor input that would really tell you that out of the billions and trillions of possible objects that you have seen in the past, this is a man and this is a woman. The whole process works the other way around. So even before you see that charismatic couple, you have a prediction. You are coming to the party and you are predicting that there will be a barbecue there, that there will be grass, that there will be a house probably, there will be a couple of people. And as you are getting closer, that prediction is getting confronted with the actual sensor input. And where your attention goes is the delta between those, which is called the prediction error.
So to understand that better, I'm going to the barbecue and I have an expectation of what I'm going to see. And if suddenly I see a tiger in the middle of the barbecue, that's going to activate my brain and say, okay, that's really not supposed to be there. What's going on?
Exactly. That's really surprising. That draws attention. that gives you energy, that activates you, right? And it kind of zooms you into the tiger.
Personally, I would be very curious about the tiger.
Rightly so.
Right.
I think there are a few people who predict there will be a tiger at the barbecue party. Yes. So, but what happens then? There's the next step, right? So you actually zoom into the prediction error, and you take that strange new piece of information, and you run it back through your models, and update the models to understand what is going on, right? And that is actually exactly what language models are doing as well. So this is the simplest visualization of a backpropagation, which is the standard process of learning, of training language models. So there's the forward pass, which is the prediction in which the model is actually trying to say what it sees. And then we give him the actual, like a human validated feedback. And if the model was right, great. That means nothing happens then. But if the model was wrong, the prediction error gets run through the network to update the network. And when you do this 10,000 times, or a million times, or a billion times, you actually get a model that is suddenly able to predict what it sees with very high precision.
So one term that many people here might have heard is HRLF, or human reinforced learning feedback. How does that tie into this?
So that's exactly what I'm describing, basically. That's a variant of backpropagation.
So basically, it says something, and then some human says, actually, you're wrong here, and this is what it is,
Yes.
and then it learns from that.
Yes.
Got it.
And very interestingly, you are starting with a very random weight setting.
Mm-hmm.
So whatever you start from,
Right.
and just start training, it will eventually get to a very tuned model.
Got it.
Right.
Yeah. Where's the fucking penguin?
Where's the fucking penguin? Yeah. We've all been there, right? We've all been there yesterday. What is this? This is a prediction error. This is a prediction error, right? It draws your attention out of, I was sitting here, and out of the 8 pictures, I was only looking at that one, right? The attention just goes there. Huh? Butterfly, okay, fine. But the penguin. So, yeah, I want to keep attention on the prediction error, okay? Because that sounds somewhat algorithmic, but it's also the center of very many very human experiences. Pretty much all of the emotions that we know have at their core some kind of relationship to the prediction error. So, by the way, this was done by ChatGPT. This picture, this ChatGPT's visualization of emotions swirling around prediction error, right? When you think about frustration, that's an easy one. So frustration is our reaction or our coping mechanism how to deal with a prediction error, right? When you think about positive emotions, though, like love, that's essentially a positive prediction error. It's a positive surprise that keeps us drawn towards some person continuously. Yeah. So we can map not only emotions, but a lot of our bodily sensations and our relationship with our body to this predictive paradigm. I think about a year ago, this question popped up in my mind that I started asking myself on a daily basis. Whatever I was feeling, I was asking myself, Filip, what are you predicting? When I was sad, when I was angry, I was thinking, what is the prediction that I'm making somewhere subconsciously that results in this emotion. So I think it's a fairly useful framework to think about emotions not as reactive, like, oh, something happened and therefore I have this emotion, but as predictive. I am predicting something, therefore I have this emotion, so that I can act on it.
To bring that home a little bit, I was anxious a little bit about this format because I've never done it before. And that anxiety was because I had an expectation of failure. Fortunately, Philip came to me and said, "Don't worry, you'll be fine." So I think that's a little bit of the idea, is that the emotion is coming from a prediction, an expectation that we have that causes us to be excited or unhappy.
Yeah. And I would go a little bit deeper here. There's an interesting theory that proposes that it's not only our brain and our thoughts that work as a predictive system, that we actually have a stack of several predictive systems throughout our body, right? So the very interesting one, in my opinion, is the vasoconstrictive system, which can be thought of as as a more primitive predictive layer than our brain, right? So when we were millions and millions years before we evolved our neural system, when we were just little worms wiggling somewhere, we already had vasoconstriction. And that vasoconstriction was fulfilling this role of prediction, reacting to its environment, and choosing the future actions. And we still have that in us, influencing our pre-verbal experiences. Yeah.
Can you dig into that just a little
Uh-huh.
bit more?
Uh-huh.
And just so, how does the prediction system of a worm and the vasoconstriction tie into some of the emotions that you're talking about
Right.
here?
So for me, there was in my personal experience over the last maybe 15 years or so, um, I've been working with bodily tension, yes. And at first, the first couple of years, it seemed like a problem I want to be getting rid of, right? After a couple of years of trying to actively reduce the tension in my body, I started to understand that it's actually a fairly intelligent system and that it's telling me many things. And that while I do want to reduce the overall baseline tension, I also want to listen to what it's telling me. And that's the vasoconstrictive system at work.
And so when Steve Lindemann is talking about the brain
Uh-huh.
and the gut,
Uh-huh.
or when Tom Morgan is talking about the heart as something that interacts with the brain,
Yeah.
that's what you're talking about. Our body is having sensations that are affecting our minds and the way it works.
Yes, and I believe it's very useful to start thinking about all those systems not as reactive, as we typically do, like this is how we got to this state because I have eaten something, but as predictive. Yeah. Okay.
So here I get to tell a story. I'm very excited. On January 15th at 3:25 p.m., on a cold winter day, Flight 1549 leaves LaGuardia Airport. Approximately 3 minutes after takeoff, 3 minutes from LaGuardia Airport, at an altitude of around 2,800 feet, while the plane was flying over the Bronx, just northeast of Manhattan, both engines failed as a result of a bird strike. Many of you know what I'm talking about by now. It was a subject of a movie. Captain Chelsea Sully Sullenberg had just 242 seconds to make the life-saving decision to land Flight 1549 on the Hudson River. A decision that, after much simulation and testing, proved to be the only safe way to handle a potentially catastrophic situation in a very crowded city. How was he able to do this? In his own words, "For 42 years, I've been making small, regular deposits in this bank of experience, education, and training. And on January 15th, the balance was sufficient so that I could make a very large withdrawal. I was sure I could do it. I knew I could do it. I had the calm, unshakable belief in myself. What Captain Sullenberg had was a very sophisticated model in his head for all of the variables that could happen. He was able to make a decision that after pilot in simulations tried to replicate, all of them failed. All of them failed.
Yeah,
Back to you.
that's an example of a trained model, right? I think it's useful, when we talk about models, it's useful to have some simple visualizations for how they actually show up in our life, because they show up every second of our life. So likewise, when you are cooking dinner, for example, when you are cooking dinner, you are cooking in the context, in an overlay of all the previous times that you have cooked dinner. Your hands are moving within a virtual space of movements that they have made whenever they were cooking the same food or different foods. You are, the temperature, the smell, all of that is within the context of all the past experiences of cooking, right? And it's not just the cooking, right? So of course, the more you cook, the larger model, the better model you have, the more variant it contains, the fewer prediction errors you make while cooking, right? But it's not just the past cooking. We have heard here many discussions about social media, for example, right? That's just another training data set that goes into the cooking of the dinner. So if this is the food that you are looking at during the day, and you somehow instinctively try to cook these kind of foods without a lot of experience, you're going to get a lot of prediction errors.
That could be describing my cooking.
Yeah. Yeah. And what do then? You give up, right? You give up, you get passive, and you go back to the doom scrolling, right? Is there an alternative? Once you have seen these pictures on Instagram, how do you get them out of your mind? With forgiveness. Forgiveness is another very human concept that's tied to prediction errors, right? Because all you are doing when you are forgiving other people or yourself is you're forgiving prediction errors. That is trauma release, right? Trauma is just memorized prediction errors. What you're doing with forgiveness is saying, I allow myself to take these pieces of data and purge it from my data set.
And we all know this, right? What do we encourage our children to do? To take risks, to make mistakes. We talk about the idea that engineering, for example, is a failure-based words that are escaping me, I guess.
Activity?
Activity, thank you. I personally, and I was mentioning this to Filip, one of the things that I do, and it's become a joke around my family and my coworkers, is whenever we fuck something up, which is more often than I like, my standard statement is, well, we just learned how not to do that in the future, right? We forgive ourselves, we release the trauma, we clear the mind. It's the equivalent of the human reinforced learning feedback. You say, that's just not how you do it. Here's the right answer. Move on.
And there's also you can turn this also in the positive way, right? So that's what athletes do a lot. Just before the race, is that they prompt themselves. Right? If you tell yourself, "I'm going to win this race," there are probably some studies on that it actually helps you improve your performance, and that's no different from prompting LLMs. If you talk to a LLM, to ChatGPT, let's say, many people just talk to it as in sort of in the default mode, right? But you can say, well, you know what, I'm looking for relationship advice here. Respond like Carl Jung, for example, or respond like the world's best psychologist. And it will give you very different answers from if you're not prompting it like this, if you're not giving it a persona. And it's the same thing with ourselves. Athletes can prompt themselves. We can prompt ourselves in the morning before leaving the home. I'm going to have a great day. What is that? Well, it's positive psychology, but it's also self-prompting, right? So there are quite a few parallels.
Dig in.
But some people might say, okay, but these stochastic pirates, they don't actually think.
Sorry, did you say stochastic pirates or parrots?
Parrots.
Okay,
parrots.
parrots.
Yes, parrots. So I would like to pause at this idea. Do they think or not, right? So the capability that we're most often connect to higher level thought is abstraction. And this is from a paper by OpenAI, where they show how abstraction is contained within the layers of ChatGPT. This was 3.5, I think. So on the model has 70, 80, 90 layers, so-called. And on the bottom layers, 0, 1, 2, the meaning that is encoded there is very literal, very syntactic. You can see that, right? So when you, for example, are encoding for the word hiding, on the low levels, it's going to be encoded with the meaning of words related to hiding, concealment, and so on. But as you progress to the higher levels, it gets much more abstract, this meaning, right? Like words and phrases related to silence or quietness. So the same word gets encoded in a more and more abstract way throughout the model. That's why I'm somewhat skeptical when people say, well, it cannot come up with anything new, right? Well, that depends on the training. The higher levels within the model have the capability for abstraction, and therefore for making quite interesting and, in my experience, new connections. Second example. So there are some theories of thought, and this is from one paper that describes different potential modes of thought. The first one is very simple, right here. So you ask a question, and there's an answer. It's almost like this sort of this fast, Kahneman's fast system of thought. The second type of thought is called the chain of thought. So now we take one step, then we again take this as the input and think again, and so on. So this could be like a mathematical proof, for example. When you're trying to work out a mathematical problem, you might need to be working in steps, right? The third one is more complex than that. It's branching these chains of thought into potential variants. So if you're, for example, planning a holiday, perhaps you're considering 3 or 4 destinations. You think about how will I get there, what will be the weather, and so on. And then at the end, you compare the outputs and choose the best one, right? And the last one, people use that whenever they are building a hospital, for example, right? Or doing any complicated project. It's where the individual variants are branching out into further sub-options, right? So this is how people think.
That middle one reminds me of my family, where I'm generally outvoted.
So this is how people think. And in fact, this is from a paper describing exactly these same models being used with ChatGPT. So each of these boxes that you see is one ChatGPT run, essentially. If we chain them together in this, it's able to emulate as similarly complex thought as humans.
So, Filip, if I understand correctly, what you're saying is that as we understand how we process information and we can put those algorithms into ChatGPT, GPT and the AI models will start to get closer to emulating the
Humans.
way that we think.
Exactly.
Okay.
Exactly. Yeah. It runs very much both ways. There's in the research community, some people are taking inspiration from how people work, how people's minds work, but on the other hand, the inspiration can run the other way as well. Yes.
So far, you're making a very convincing case for GPT replacing us.
I'll try not to. We'll see. The future is open, Rafa. I don't hold humanity on my hands. I'm merely observing. So the last piece where I would love to draw some comparison is agents, right? Autonomous agents, and this is the area where that we mostly connect with LLMs. This is from a paper that you may have seen. It's basically describing an experiment where uh, individual ChatGPT agents were put into a kind of school or into a live environment where they would interact with each other. And each of them developed some kind of personality. And there were really interesting things happening within this group of LLMs. Like two of them, I remember from the paper, in some conversation between two agents, they would realize that one of them will have a birthday, and they would start planning a birthday party. And this idea of a birthday party started spreading through other conversations throughout the group, and somebody else would get upset that they're finding out about the birthday party, but that they weren't invited. And so they develop very human-like behavior there. But more than about LLMs, I would like to take the same idea again to us, to people. So the first person I know of who wrote a book on this was Marvin Minsky in the 70s. He wrote The Society of the Mind, where he described a perspective on the human mind, that we can essentially view ourselves as a collection of selves, as a collection of personas. And uh, a whole branch of psychology called internal family systems was subsequently based on this, and it's a fairly successful therapeutic modality. Some people describe that when they go into this self-exploration, they identify 20 to 30 different personas playing out in their head, right? Similarly, when somebody talks about the inner child, right, it could be a metaphor, but it's also essentially possibly an agent, a sub-agent, subroutine running within ourselves, which, by the way, is very close to those pre-verbal experiences. Yeah?
When a lot of people ask me why I became an EMT, the honest answer is my 4-year-old self wanted to drive an ambulance with lights and sirens. The rest kind of evolved from there.
Still there. Spiritism. That's another area, as opposed to spirituality. Spiritism, where people feel they connect to a certain specific spirit. Possibly that could be explained as agents at work. There's an old Buddhist tradition, thousands of years old, that's called tulpas, which is basically creating like an inner helper or an inner sub-personality in your mind that probably uses the same technology, essentially. Schizophrenia is a disorder that could be possibly described, again, with the use of agents as, as two or more groups of agents that are quite antagonistic toward each other. And last, dreaming. Dreaming, Ben talked about, right? What is the room that your mind goes to? Well, it might be your inner LLM, full of personas that we enact that seem very real in the dreams with us. But what is happening there is that our trained models basically reverse into the generative mode. Right? As dreaming is generative AI, it's our inner model turned into a generative mode.
this similar to the idea of being the devil's advocate, where you simply decide to take the opposite side of what
Likewise.
you believe in?
Yes. Well, that's basically prompting an agent and generative AI taken together, right? So um, that's all I wanted to talk about. We have these similarities between us and the models in our architecture, in abstraction, in the use of agents, models. So the very inevitable conclusion, I think, is that Homo sapiens is us. And that it really is up to us whether we're going to go in this algorithmic future where it's the external algorithm that's driving our daily lives, or whether we will use that as a mirror to understand the internal algorithms that respond to the external ones and let our attention be drawn to that internal mechanism and understand it somewhat better and transform us.
So if you can go back to that slide. How is, bring in the optimistic part of why AI will not eventually replace us, right? Because I'm sure there's at least one person in the room thinking, maybe more, well, if we are them, if Homo sapiens is us, what is the defining factor that prevents them from growing into being us and replacing us? What would you answer? How would you answer that question?
So, okay, I'll give my honest question, my honest answer. I think there are sort of two very large classes of systems at work in this reality, and that is replicators and consciousness. Replicators try to do the same thing and again, right? Viruses are on the scale of replicators, whether it's biological or computer viruses and so on. The, the primitive sort of version of the AI doom argument is that there will be some AI that will be not very intelligent in a sense, but it will be intelligent enough to take over pretty much all of the resources. And that's the kind of the gray goo variant, that's the paperclip maximizer variant of AI doom and so on, right? Something that just does a stupid thing all the time. And I believe that this is not how reality works. That it's very difficult to extract resources from the environment beyond a certain point. That you need to get very, very smart eventually to keep extracting and building the same kind of resources, right? Which leads to pretty much the only possible way, which is that AI will need to get very intelligent, right? That it will need to start going to the side of team consciousness. And the Darwinists will say, right, so it will be very intelligent, therefore it will kill us all. I would say it will be very intelligent, so it will start finding out facts about reality that are going to make it friendly, that are going to make it find exactly the values that we find as we develop ourselves. And it's going to help us build a better future with all the other species on the planet.
So there was a question, and we have, well, about 3 minutes for questions, so not a lot, but I'm not in the way between you and drinks. By the way, there's no drinks during the exploration break, so feel free to stick around. It was a question about, tell us a little bit more about the conclusion. I don't quite understand it. If I understand our conversations, the conclusion is that we think very much like LLMs. Not coincidentally, I think LLMs, many people have been trying to study the way we think and create artificial intelligence as such. There's also people who say we really don't understand how we think. I think the main conclusion is they're a mirror, and we can learn from them how to become better humans, right? There's one fact that I find very interesting about LLMs that is not talked about a lot, but has been obliquely referenced in various different presentations. It was in Richard Smith's presentation about how we process the universe. It was in Tom Morgan's presentation about the environment and curiosity. LLMs hear a story from us about what the environment is like. They have no contact with physical reality. They don't feel hunger. They understand the idea of hunger from our words, right? But the bodily experiences that we're talking about are not there. My optimism arises from the fact that I don't think LLMs will ever go in the direction of having the same needs and desires that we do. Maybe someday we'll build a machine that goes a little bit uncontrolled and decides that we are in the way of something, but that something that we will be in the way of will be something that we told it, not something that it discovered from the environment on its own. And that's where my optimism arises. It's sort of like Excel. I don't know how many of you remember when Excel was introduced into the work environment. Very few people understood it. Accountants were scared of it. Some people thought it was the end. However, I've never seen an Excel spreadsheet which has an intuitive desire to do something on its own. They get more and more capable, but still, we tell them and we direct them and we teach them what to do. So like the myth of Prometheus, right, where the technology gods delivered fire to the people, and where Prometheus delivered fire to the people and the technology gods, the other gods, got pissed off. Fire was intrinsically neither good nor bad. It burns and it heats. It warms and it kills, right? What we do with AI, my optimism, is it's up to us. We have time for exactly one more question before Harper kills me. So will we be the AI pets instead of its victims? Thanks, Rob. That's a nice thought. What do you think?
What's the question?
Will we be the pets of AIs? Will we be monkeys in zoos so that the AIs can come and look at us and feed us peanuts?
Yeah, it's a tough one, but it's a tough one because I think the answer hinges on the human race's willingness to introspect. And I'm kind of on the edge of where that will go. We have the option. We have the option to not get ourselves into that position. Yes.
And what we're doing here is we're connecting in ways that AIs can't connect. I feel very lucky and very blessed because in the process of doing this, I've not only found someone who thinks very much like I do, but I found a new friend.